The standard deviation, same idea. The difference here is that the standard deviation is always, these problems, they're always symmetric. They give you a graph that has a mean in the middle here is at 8, and that mean is at 8, and this mean is at 8. So it's always split down the middle, and the two sides are exactly the same as what symmetric means. See how it says each distribution is symmetrical? So the idea is, in standard deviation, are the measurements moving away from the mean, or are they moving closer to the mean? So we're going to do the same thing. I recommend you print these out, and you let the first one be your starting point of 0. And what happened? Well, in picture B, the third block on 7 moved to 6, and the third block on 9 moved to 10. So we moved out, away from the mean. So the 7 went down to 6, the 9 went out to 10. So 2 blocks got moved 1 space farther from the mean, so the standard deviation is larger. We'll call that a +2. In C, we had 3 blocks on 7, but now we have only 2. It moved down to 5, so that's a move of 2. So 2 blocks got moved 2 spaces farther from the mean, 1 on each side. So the standard deviation is larger by +4. So what's the order? Well, A is the smallest at 0, B is next at +2, and C is the largest at +4. Okay, are there any questions? Okay, remember this is recorded, so I know I'm going fast. I was hoping to work a lot of problems for you so that you can have this as a reference. I'll post these videos so that you can go back and look at them again. If your block moved closer to the mean, then you would have a negative change. In this case, both times the blocks moved away from the mean, so your standard deviation increased, so we're working with positive numbers. But if they had moved closer, it would be a negative change for your comparison. Okay. Okay, so it ends up in the same order, A, B, C.